All right. So let's say we're done the pilot study. Question is good. Let's say continue. Here sample size must be bit 100, 100. So the purpose is to study the underlying structures among variables. Administer the questionnaire on the same target variable, target population. If no changes were made from pilot study, you can consider the cases for factor analysis. Changes were made from the pilot study, then you can't use the data from pilot study. So here, you talk extraction method, rotation. Extraction method, later we'll go and see into the analysis, must be principal axis factoring, not principal component. There are more than one component, then we do rotation. Right, before that, let's look at this now. What's the basic difference between these two graphs, charts? What's the basic difference?
The
So here,
direction of the arrow?
direction of arrows. Circles are latent. The boxes are indicators of the observed variable. Example questionnaire, this question number 1, 2, 3, and so on. Right. So supposing this is from my questionnaire. Example, let's say you want to know uh, perceived remuneration. Perceived remuneration. Right? So the perception, how the thing is inside the head. The perception on remuneration resides inside the head. How to bring it down onto the paper? How to bring it down onto the paper? We ask some questions, isn't it? Is that right? Class,
Yes, Prof.
we ask some questions.
Yep.
Based on the question, as we did just now, we're going to tell whether the perception up here is it positive or negative. Supposing this question 1, 2, 3, 4, 5, each one measured on a Likert scale of 1 to 5, let's say. Likert scale of 1 to 5. Okay, let's say Likert scale of 1 to 5. 1 means strongly disagree, right? 2, 3, 4, and 5. 1 means strongly disagree. 5 means strongly agree. Example, the question just now. My salary wage is fairly fair considering what other people are paid. Let's say strongly agree. That means what? He strongly agree to this means what? His perception on remuneration is positive, right?
Yes.
Right. Same thing with all the other questions. He marks either 4, 5, 4, 5. That means inside the head, he perceived remuneration be positive. Which one came first? The perception came first or the questionnaire came first? Perception came first, the questionnaire came first.
Perception.
Perception came first. We devised the questionnaire to measure what's inside the head, right?
Yes.
So what he answers here depends on what's inside the head, right?
Yes.
So they are called, so these particular indicators are called reflective indicators, reflection of what's inside the head. You want to measure what's inside the head, how they perceive it. So we give a series of questions. Example, each question answered on a scale of 1 to 5. 4, 5 means they're agreeing. 1, 2 means disagreeing. A person marks, let's say 4, 5 for all the questions, either 4 or 5. He or she telling their perception is good. If another person answers 1 or 2 in all items, then he is telling his perception, remuneration is not happy. So that's called reflective indicators. On the other side, what's the difference? What's the difference between number 1 and number 2?
The arrows are pointing
The
towards.
arrows are pointing upwards. So they are formation, right? Examples. This, let's say, a student's performance. Students' performance in school. Students' performance in school. Depends on what? What can be Y1? The student's performance in school may depend on,
Grades.
no, this is a performance school. How you perform in school. Can it depend on father's education level? Father's education?
No.
No. The child's performance, can it depend on parents' education level?
I don't know
They
actually.
don't actually, not necessarily.
Not necessary,
Not necessarily.
but most of the time, educated parents, children, do they perform better? Suppose a person is
Yes.
not educated, all right? Will they be able to help the children? Not educated at all.
No.
No. The parents are educated. Will they be able to help the child?
Yes.
Right. The number of tuitions they go for,
Definitely.
right? The income of the family,
To some extent, yes.
some extent. Number of siblings,
Oh, definitely.
Yeah.
okay? So the parents' education, mother's education, father's education, income, number of tuitions they go for, and the number of siblings they have, they may they form this particular structure, right?
Yes.
Performance in school. So these are called formative indicators. Formative indicators. Supposing the Y3 is income, Y4 is number of tuitions. Suddenly, the parents lose their job. What happened to Y3? What happened to Y3?
It would
Y3 is the income. The parents lose their job. What will happen to Y3?
be affected. They'll go down.
Go down. Y4, number of tuitions,
Maybe go down.
go down. The tuition goes down. Is it possible the performance become poor?
Yeah, it's possible.
Possible. So these are formative. By changing this, we are able to change this. Whereas here, this already fixed up there in the head. This is what we observe. Based on what you observe, we make a conclusion about what is inside the head. Whereas here, these are called formative indicators. Formative indicators. We're able to visualize or predict what will be up there. Example, let's say now, Y1 is BMI, Y2 is waist ratio, this is bicep, subsep, and all this. When the values are very high, BMI very high, right? Your BP is very high, sugar level very high. All this means what? BMI high, BP high, sugar level high means what?
This person is not well.
Person not well. By lowering the BP, lowering BMI, lowering BP, lowering sugar level, can he reduce this better his health?
Yes.
Yes. So modifying this now, I can modify his health. Whereas here, your question is fixed. What you measure here depends on what's inside the head. So they're called reflective indicators. At least most of the time, your questionnaire, they are reflective indicators. Just now, we talk about remuneration. How many items were there in remuneration? How many items asked?
4.
4 items?
Yeah.
Right, 4 items asked here about remuneration. My salary, wages, all this. So when you go and dig his brain, ask him to answer this, right? Isn't it? Put on paper, you mark either 1, 2, 3, or 5 based on what you consider, that means perception already inside the head. So he answers these questions here accordingly and be able to see what must have been his perceived perception on that concept. So here, this class, we're going to talk about only this, reflective indicators. So whatever all this remuneration, all this, these items, which are called indicators, they are reflective indicators. In this case, often think of thinking inside the head, right? It's possible, right? It's all inside his head. So they collectively measure intention leaf. We want to know what is level of perception on intention leaf. By looking at the answers he gives, supposing 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, all the items. 4, 5 means very likely. 1, 2 means not so likely. So answers 4, 5 to all the items. What's telling us? 4, 5 means yes, 1, 2 means no. You're answering all the questions 4, 5, 4, 5. What's telling us?
Person wants to leave.
The person wants to leave. Another person answers all 1, 2, 1, 2, 1, 2. What's the person telling us? Another person answers all the questions, either 1 or 2. What's telling us? Yeah?
Has no intention to leave.
The person is not going to leave. So intention inside the head, how to measure it? We prepare questionnaire like this, and we call them indicators, and these are called reflective indicators. So basically, we want to know what is inside the head. So they'll be assessed based on what kind of response the person gives. Right? Positive response, then the person may stay. Negative response, the person may want to leave. So that's all. What's the objective? Just now, what's the objective? Factors associated with intention to leave. So test one by one. Remuneration. Next, job challenge. Next, career development. Next, intention to leave. And then later, we're going to do further analysis. So we're going to do exploratory factor analysis. Now we're going to look at the same thing as just
Oh,
now.
Sorry,
Yeah.
I just have one question on slide number 19.
Yeah.
So formative indicators, could it be more for qualitative?
No,
Not necessarily.
all these are quantitative,
Okay.
right? Even the qualitative analysis also, we are asking questions to dig what inside the brain, right?
Yeah.
What they say is still what's inside the head, right?
Mm.
Right, reflection of what they feel. You're asking what they feel about this. The feelings inside the head,
Okay. Okay.
all right?
Thank you.
So what do you look for? Same like just now, standard deviation must be not 0. Correlation between 0.3 and 0.7. So these are additional. Something called Kaiser-Meyer Alkane, and the average variance explained, and finally vector loading. So we'll see this in example as we go through. So first two, we've gone through just now. In addition of the two, we look at 3 more. Basically, what you want to know, are these good indicators of what's inside the head? Are they good reflection of this? Sometimes call it dimension, right? This item, do they form one dimension inside the head? Later I'll show some variation, which is, right? How to detect that. All right, so this is what we're going to do. We do later. Okay, these are points. As we did just now, this is what we're going to look at. 1, 2, 3, 4, and 5. What's number 1? Number 1,
Standard deviation.
Number 2, correlation. Right. Number 1, are they all more than 0?
Yes.
Yes. Correlation. How do you circle the highest value in each column? Are they all between 0.3 and 0.9?
Yes.
Right. Next addition, ask for Kaiser-Meyer Alkane. That means, can they be reduced to smaller dimensions? So this value, Kaiser-Meyer Alkane, is it more than 0.7?
Yes.
Right. More than 0.7? Yes. They can be reduced into smaller dimension. This one, number 4, how many factors? Number of factors. On the left-hand side, how many rows are here? How many rows?
4.
4 rows.
On the right-hand side?
1.
1. That means the 4 can be reduced into one factor, which means these 4,
Mhm.
house 4, right? The 4 items are actually coming from one factor, right? We should do some variation later. All right. This is called percentage explained variation. It's like R square. What's R square? What's R square?
Correlation.
R square we did in regression.
Yeah.
Cause and effect.
Yes.
Oh,
The residuals and the regression.
R square is percentage explained variation, right?
Yes.
Isn't it?
Yes, it is.
Right. Shall I analyze item one by one or collectively one variable? This one variable, does it represent the 4 variables? That's what I'm asking. The 4 variable, does it represent the 4 variables? The one variable, does it represent the 4 variables? Right? 1 represents the 4. If yes, how much variation is explained? This is like your R square. So we're saying the one factor explain 60% of the variation in the 4 items. We'll see some variation later. Now on this side, who's talking there? Right. Imagine 1, 2, 3, 4. 4 people went for holiday. 4 people went for holiday. On this side, how many rooms they took? How many rows?
1.
1 row. So it's like 4 people went for holiday. They took up 1 room. That clear?
Yes, Prof.
That means the 4 item belong to. The 4 item belong to. They are good reflection of that concept. The 4 items are good indicators of that concept up there. Okay, we do some variation later. This is factor matrix. We call it factor loading. So what I'm looking for is this factor loading must be at least 0.5. So what do you look for? Standard deviations, correlations, K-more value. Okay, K-more value. The 4 now become 1. That means a single factor was extracted that explains 60% of variation in the 4 items. And the minimum factor loading is more than 0.5. So this is how the writing going to be. Result from factor analysis. There were 4 items in the enumeration construct. Descriptive statistics inter-item correlation values are shown in table X. So this is descriptive. We look at the standard deviation. They are more than 0. And this is a correlation matrix. The highest value in each column, right? The highest value in each column. Are they all more than 0.3? Is it more than 0.3? Class?
Yes.
Yes. Second one?
Yes.
Yes. Third one?
Yes.
Yes.
Last one?
Yes.
Yes.
Are they all in this range? Are they all in this range?
Yes.
Yes, that's clear. So point number 2 is clear. Hence, the item correlate adequately in the construct. In the factor analysis, Kaiser-Meyer-Olkin value So we got it from this table, was 799. Anything more than 0.7 considered to be good. And in the analysis, the 4 items became one factor. The 4 items can be reduced into one factor. Single factor was extracted. And that explains 60% of the variation. And then the minimum factor loading, I don't go in detail of this, is 0.570. It's like your regression coefficient. And that's a value. If all these are fulfilled, you can take the average of the 4 items to represent the remuneration concept. All right? Let's say I'm going to do that. Just watch on, then you do it. We do it together. So now we did for remuneration. There are 4 items here. Let's say I do the mean of this item. So I put remuneration, right, equals to mean of the 4 items. Okay, let me bring this nearer to. All right. Look at this now. This was computed. This value is all 4, 4, 4. So that's average, right?
Yes.
This value,
Yeah.
2, 2, 2, 2, that's 2, isn't it? Look at this now. This value. So small value means what? Look at this small value means what? Why the value is small? Because the average is small, isn't it?
Yeah.
Yeah, the
Right?
scores are lower.
Lower. So high score here means is positive. Low score means is negative, right?
Yes.
High score here means is positive in all the questions given. Low score means is negative in all the questions, is disagree. He perceived remuneration is not good enough.
Yes.
But he perceived remuneration is good enough. But before doing this, he must go through the process of factor analysis, right? The steps, check this, all okay. Then only we can average. All this met, then only can average. If either one of them is not met, then must drop some items and then redo the analysis. Okay, this is the end in mind. Ultimately, you're going to say how good your items are in measuring that concept. Okay, let's start. How to do it? Okay, follow the instruction. The data is data for factor analysis. Are we ready? Class, are we ready?
Yes.
Right. Open the data for factor analysis and do exactly the same. Right. Analyze dimension reduction. That means the 4 items there can I reduce into smaller dimension. Factor. Which construct? Items on remuneration. All here. And then click on descriptives. Descriptives. Ask for univariate. They'll give the standard deviation. Ask for coefficients. They'll give the correlations. And ask for KMO. Whatever is clicked here. Continue. Next, go to extraction. Extraction. The principal component is for formative indicators. Ours, are they formative or reflective? Ours is formative indicators or reflective indicators?
Reflective.
Reflective. So don't use principal component. This is formative. Change it to, most of the time, use principal axis factor. Remember, principal component is formative indicators, but ours is reflective indicators. So choose this and click OK. That's all. Click OK. Okay, look at the results. Point number 1. Are they all more than 0 correlations? Sorry,
Yes.
standard deviations?
Yes.
Okay.
Yes, the standard deviation is less than 0.
Right. The highest value here, 0.71. Right. 52, 71. The highest value between 0.3 and 0.9.
Yeah.
Three more value,
Mm,
more than 0.7.
More than 0.7.
Right. Now come to this table, extraction. There are 4 items here. They can be reduced into one factor, and that explains 60% of the variation in the 4 items. That's good. And the minimum factor loading is 0.570,
Mhm.
right?
Mhm,
You will
yes.
report it. Report it. So don't have to report all the tables. First, the mean and standard deviation. Now, this mean and standard deviation, are they towards lower side or higher side? Our scale 1, 2, 3, 4, 5. Are they lower side or higher side?
Slightly higher.
Higher. My scale 1, 2,
Low.
3, 4, 5.
Lower.
Lower. Below 3, right?
Yes.
Let's say 3 is somewhere in the middle. So generally, they're not happy with the remuneration, right?
Yes.
It's
Not
lower
happy.
than 3, right? Lower than 3, isn't it? Generally, they are not happy. We want to add
Not
that.
happy.
We can add one more statement.
Mhm.
Generally, the perception is low, isn't it? Except for 1. The next, correlation on this side, and comment on this. Next, KMO, read there. So what does it mean? The analysis, 4 items reduced into one factor, and that explains that much of variation. And finally, this value, minimum value 0.570. Let me show you some variation. So let me create one variable. Three. Like just now, I'm creating one random variable. 1. All right. So I just created one more variable. Let me call this remuneration 5. Okay, bring it closer. Let's say now I have 5 variables. 1, 2, 3, 4, 5. So let me show you the factor analysis on this. The 4, and I bring the 1 here. Rest all exactly the same. No changes. Extraction. Okay. So let's look at the tables now. Standard deviation, is it okay? Standard deviation, is it okay?
Yes.
Right? Sorry, I add one more 5, right? I don't know why this value is very high. Let me redo it. I want this to be random, variable, normal. Okay, try one more time. Hold on, now I want to make the particular variable weaker. Okay. Standard deviation looks okay. Second table,
Yes.
correlation. Is it good?
No.
No. Right, the correlation is weak. Therefore, this item must be removed, right?
Yes.
Right.
Mhm.
KMO, is it okay?
Yes.
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 More than
Yes, it's okay.
0.7.
Right. Now, how many factors are extracted?
2.
5.
Two
Huh?
factors extracted.
2. Yeah.
Isn't it?
Yes.
The 5, 2 factors extracted. Listen carefully. 5 people went for holiday.
Mm-hmm.
They took up how many rooms?
2 rooms.
2 rooms. So what's the next question?
Which one?
How many people in each
Say
room?
again?
How many people in each room?
Oh, no. 5 people went for holiday. They took up 2 rooms.
Mm.
How many in each room?
Who is in which room?
Oh yeah, sorry.
Isn't it? Isn't it?
Yes.
Who is in which room? So we thought all the 5, and one more here, the fifth one, all belong to one construct. Actually, there are 2 dimensions within. Out of 5, they went to 2 rooms. Next question is, who is in which room? But observing this, I could drop this, right?
Yes.
So what I'll say here? What will I say here? How to justify this now? There are 5 here, right? So what will I say here? The maximum correlation value for item, example 5, was less than 0.3, right?
Yes.
Hence what?
Mm.
Hence, item 5 did not
Not
correlate
correlate.
with the other items. With the other items in the construct. Did not correlate with the other item in the constructs. Okay, other items in the construct. So what are you going to do? What are you going to do?
Drop it.
Drop it.
Hence, item 5
5.
was dropped. Hence, item 5 was dropped. I'm just showing an example, okay? This item did not fit well. So item 5 was dropped. Right? Of course, we'll show it here, right? Show one column here and this one here.
Yes.
So now, this is after dropping. After dropping item 5. After dropping item 5 in exploratory factor analysis. In exploratory factor analysis. Okay, now I go and drop this. Do analysis again without this item, as I did just now. What changes now? KMO is there. I don't have to repeat this again because I already made a decision to drop it. So I go to KMO. So what's the KMO value?
0.799.
Good. Now how many factors? How many factors now?
One.
Factors.
Only one factor.
One factor.
That's good for us. It's supposed to be renumeration. Be conceptualized as one factor. Comes on one factor is good for us. And your factor loading. So this is a variation. It's not all okay. And you find the mean, use for further analysis. Over here, one item did not fit in well. So what decision made? Drop it. After dropping item number 5, perform the analysis again and report your findings. Are we clear? Okay, what we did? We did factor analysis. We got these tables 1 to 5. First table, observe, you are more than 0. Second table, between 0.3 and 0.9. Third table, the K more value. Fourth table, we observe the 4 can be reduced into one factor, and that's explained variation, and that's our factor loading. Are we clear?
Yes, Prof.
All right.
I have a question here.
Yes, Prof.
Do we need to do the reliability analysis first, and then we have to do this exploratory factor analysis?
Okay. Some
Or we
people,
can.
some people after this, they do the reliability as well. But for me, it's not necessary. But you want to do is fine. Okay. Do the reliability again. Scale.
Okay.
Reliability. You want to show both, also can. So normally we don't go detail, only the alpha. So what's alpha value here? 0.854. So you can add that in your write-up. Okay, besides all this, you can write the add on here. Okay, somewhere here. In or the Cronbach alpha. The Cronbach alpha value. Cronbach alpha value was how much? 854. 0.854. Right? I can add this statement. Right? No harm.
Okay, but is there is this like under this condition we have to do reliability analysis?
No, whatever done is much more powerful compared to Cronbach alpha. Right?
Okay. Okay.
Only talk about internal consistency. But here we're asking the item, are they coming from that construct? Right. We're asking whether the items are coming. Hold on.
Yeah.
This item, are they actually coming from this construct? They're corrected for each other. Whereas Cronbach alpha is based on pairwise correlation. Pairwise correlation. So scores from factor analysis are more stronger compared to this. But some authors or researchers, they still want this, give it to them, no harm. Right?
Okay.
All right.
Thank you.
Okay. Let's do the number 2. Factor analysis. Factor analysis. Let's take this out. Just bring in this variable. Descriptive, you already set. Abstraction, make sure this is not principal component, this formative indicator. Click OK. Okay, let's report this. Standard deviation, all okay?
Yes.
That's the value we're reporting here. Correlation, are they all okay? Correlation, this value. this value,
Yes.
this value, this value, right? Clear. AMO,
Yes.
3. Is it good enough?
Yes.
How many factors are selected?
1.
One factor. Four of them become a single factor. But the AVE, exponent variation, is it good enough? How many
No.
percent? Only 40%.
Yes. Yeah, less than 50.
Yes. So I want to improve this. What to do? It's not enough, then what to do? Look at this matrix here. Which is the lowest value?
154.
CD2.
But remove this item. Maybe this will go up, right?
Yes.
But remove this. D2. Look at D2. Compared to others, D2 a bit low, isn't it? Sorry, D2.
CD2, yeah. 2, yeah.
A bit low, right? Here got 0.4, right? This is a bit low. Let me try without D2 what happened. I drop D2 and run. Is it improved? Slightly,
Yes.
slightly. Let's say still I want this to be more than 0.5, 50%, let's say now. Which one will dropped? Which one need to be dropped?
CD1.
CD1.
CD1. I drop CD1. Is it much better than just now?
Yes.
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 So if our focus is this, our focus is this must be at least 50%. We go into the table and say how to improve it. The smallest being, I won't drop both together. Smallest is this value. I drop CD2 first. After dropping CD2, 3 items, still not enough. Dropping C1, okay, more than 50%. So factor analysis is not the end, so it means for further analysis. So finally, I want to know, now I did for ITL, sorry, let me do this all this again. Hold on. Okay, first I did for remuneration. You put R value equals to mean of. So since all the 4 variables are good fit, all right, I keep it aside. Next one. This for which variable? CD, right? Are you with me?
Yes, yes.
CD, I found that only 3 and 4 are good, right?
Yes.
3 and 4.
4.
These 2 items are good indicators, not 1 and 2. I saved it. So as I go, I'm going to say the mean, in this case, of the 2 items, right?
Yes.
Right? Were computed and used for further analysis. So in this case, how do you do this now? How do you report in this case? First, here, is it okay? At first, are they all okay? The first statement,
Yes.
Yes.
right? So this is for this construct.
CD.
So this all were okay. KMO, is it okay here?
Yes.
I'm talking all the 4 items. KMO is also okay. Was it a single factor?
Yes.
Yes, single factor. But this only 40%, isn't it?
Yes.
So I'm not happy with that. So here I talk about factor loading. This is a factor loading. The factor loading for, here I put FL, factor loading for items 1 and 2 were low. right? After dropping these two items, they extracted the variation, right? I call it AVE, two items. The AVE was, so drop one by one, 44. After dropping the both 51%. Right? So this is not good enough. That means still some weakness there. So now item 1 and 2 dropped. After dropping this, AV was 51%. So now the minimum factor loading is 712. We try the Chromebook Alpha. Just for 2 items. CD 3 and 4. Right, 0.674. Quite close to 7. And then find the mean of the 2 items. See how you're selecting the items to represent the construct. See, in factor analysis, so in reliability analysis, all 4 went through, right?
Yes.
But in factor analysis, are they coming from a single dimension? The 1 and 2 are not that strong. So drop the 1 and 2 and then maintain 3 and 4. But you don't show anything here. Okay. In this case, just leave everything. As you do the analysis one by one, bring in step by step how you're improving the construct. So in construct number 2, we'll only 2 items. That the 2 items are good representation of CD. Are we okay?
Yes.
Okay, let's do one more. Number 3. Factor analysis for construct JC. JC. Again, check. All done. Extraction done. Click OK. Check the tables. Correlation, are they okay?
Yes.
KMO okay?
Yes.
How many factors?
1.
One factor.
How much explained?
Yeah, more than 50.
Okay. But the minimum factor loading for JC1 is less than 5, right? 0.5, right?
Yes.
It's almost 5.
Almost. Supposing this item is very important, I just keep it. Right? I just keep it. And say the minimum factor loading was 0.496. Right? 0.496. Right?
Yes.
There's no harm. If I feel that item number 1 is not necessary, but I want to improve this, what do? I drop this item. So drop this item, JC1. Is it much better?
Yes.
It's not 50%. 50% with item 1, and the loading is a bit low. So when I drop that, 3 items, 1 factor. So this is much better. And all the factor loadings are more than 0.7. If I do this now, I'll compute this for which variable?
JD.
JC.
JC.
JC. I'll do the mean for JC2, JC3,
3,
and JC.
just 4.
So these 3 are strong indicators of JC. All right?
Yes.
All right. The last one. Okay, last one. Okay. Correlation, is it okay?
Yes.
AMO okay?
Yes.
How many factors?
One factor and more than 50%.
All right. Minimum factor loading?
Yes.
All right. So these 4 items seem to be good indicators. So ITL, mean of ITL 1 to ITL 4. So factor analysis is not the end, it's only means for further analysis. Now, why am I doing all this? What's my ultimate aim? What's my objective? My objective is still, where is it? Factors associated with this one, right?
Intention to leave.
That's my objective. Now, our score for all this already now, right?
Yes.
Yes.
As if all these are boxes. As if all these are boxes. So look at my data, the last columns. So these are the scores. Scores for ITL, R, CD, and JC. So these are my scores. These are like measured variables. Now, what do I want to know? What do I want to know? Whether, what's my objective?
Association.
ITL, does it depend on remuneration? CD,
C and
and
J.
JC. How many variables here?
4.
4 variables. Are they quantitative or qualitative?
Quantitative.
Quantitative.
Quantitative. Which is dependent variable?
ITL.
ITL. Independent variable?
R, CD, and JC.
So what analysis will you do? What analysis will you do?
One.
No, regression.
Eh?
It's regression.
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 Simple or multiple?
Multiple.
Multiple regression. Okay, let's do this. Dependent. I already have this. ITL. Independent. This 3. I don't want to go into details. Just click OK. What the ANOVA table say?
There is a dependency.
At least ITL depends on at least one of the 3.
After that. Yeah.
Right. Which one? Which one? Does it depend on remuneration? Or
Yes.
Yes.
CD?
Yes.
JC?
No.
No.
Right? JC, no. Right? So multicollinearity, you can check. Statistics, multicollinearity. Is there a problem of multicollinearity?
No.
Yes, it's less than
Or less than 5?
5.
Less than 5.
So that's what ultimately I want from my study. Okay, results from factor analysis. I will run my copy. Right, that's what I want. That's why we did so many exercises on this. Okay. What's the objective? What's the objective?
If intention to leave
Factors
depends.
Associated. associated
with ITL.
ITL.
So here what analysis? Results from regression analysis. Right. Results from regression analysis. Okay. So the mean ITL score obtained from ITL score, okay? ITL score was regressed on mean what values? Remuneration, CD, and JC
You see.
values. The results are shown in, let's say, table X, table Z. Okay, that's my table Z. Okay. So what's the conclusion now? What is the conclusion? Conclusion? Come on. How do you write the conclusion?
There are three variants.
ITL depends.
As shown in table
Table
that ITL
depends on
R and CD.
only
R and CD.
R and CD.
R and CD. Are they positive or negative?
Negative.
Negative. Higher the
ITL.
R and CD
Lower the ITL.
over
Lower ITC.
attention to here. Right? Okay, this is a negative. So they're happy with the remuneration, happy with CD, they are more likely to stay. But what's the R square? What's R square?
14%.
14%. However, only 14% of the variation in ITL is explained by R and CD. What does it indicate? What does it mean, the last part? Only 14% explained. Is it?
Other variables.
The other percentage depends on other factors.
Right. So study results are not very conclusive. For some reason, we took only remuneration, CD, and JC. But we found that the results are not very conclusive because only 14, whatever it is, it can't change now. You just started with this, only 14 for explanation. Don't go and change after this. Right? I'm going to run through from beginning. Right? We wanted this. We wanted to answer this question. This is my model. These are my hypotheses. So where do you start? So explain the concepts and how we measure it. So we did instrument, questions. So in this case, we test the number one internal consistency, and also statistical validity through factor analysis. So initially, we operationalize each one by these items. Next, content validity. We give the item to some content experts and content validated. The next, items okay, we'll pilot study. Basically, you want to look for internal consistency. So we did the study and we did the analysis. Let's say we found all these are good enough. All this chapter 3. Chapter 4, you're going to collect data to answer the objective. So minimum sample size 100. Collect the data. And then we want to know whether these items are good indicators. Just now we saw remuneration okay, ITL okay, but the CD only 2, JC only 3. How do you know that? So we did the analysis. So step by step, right? For 1, we report this. So report the same thing for remuneration, for JD, for development, and also for ITL. And finally, I want to answer this question, my objective. So what do you do? Results from regression analysis. So mean of this, results are shown in table X, is that? So these are results. So based on this table, we can see that your ITL depends only on these two. There's no problem of multicollinearity. However, only 14% explained, right? Is it good or bad? 14%.
It's bad.
Bad. So it'll pass or will fail?
Fail.
No. Initially, my objective was only this. Some or other, the committee in the panel in the defense proposal defense all agreed upon, I go. Finally, I report this what I have.
Does this 14% indicate the questions are less, or it's like the number of factors, the variables considered are less?
Yeah, not sufficient. So what is your recommendation? Recommendation to tell these 3 items are not
Sufficient. Yeah.
right, efficiently measuring ITL. There should be other variables such as what? Because your literature will continue, right, towards the end of your study, isn't it?
Yes.
So the end of the study, let's say you started 2020, now already 2021, you finish in 2022, a new research done, new results coming in, then you can include this. Or besides these variables, other variables like what? Other variables like, look at the data.
Infrastructure facility.
Do you have other variables? Gender,
And
qualification, monthly income, length of service. Will they matter? Will
Yes.
this matter?
Yes, they should matter.
Right. So can I use regression analysis for this?
You can use logistic regression.
No, we do general linear models. Right. So this alone doesn't explain much. So still ITL might dependent. These are all quantitative variables. They'll go into covariates. This variable, gender, all these are qualitative variables. They'll go into
Fixed factor.
vector and model, real terms, all these variables inside. Sorry, main effects, all the variables. Continue and click OK. Okay. Which factors are significant now? Is this still the same?
No. R.
Still the same?
R and CD.
Still the same, right?
Yes.
Yes.
This is R square. R square still about the same, 16%,
Yeah.
right?
16%.
Right. Even these variables did not contribute. So back to this only. Say that or your questionnaire is not good enough. We don't know yet. But questionnaire, we can't complain now. Why? We took it from some sources, we content validated, we pilot tested. We can't go back and say your questionnaire is not good. Looks like the other variables besides all this. Supposing these all variables, these are only variables in the literature. So now I can say among all the variables, only these two are significant. Then they explain only about 16%. The suggestion, there could be other variables which could be important in predicting intention relief. Okay?
Yes.
So factor analysis is not the end, so any means for further analysis. So, but see, what you learned earlier, regression analysis, come in handy, right? Isn't it?
Yes.
And your general linear model come in handy, right?
Yes.
So this will be used somewhere. That's why I emphasize so much on your regression, multiple regression, general linear model, and also logistic regression. Right? And the end, even in the questionnaire, the variables can be summarized into based on factor analysis, save the scores, and finally answer my objective. Among the tested variables, only these two are significant. How does it work? These two are significant. How does it work? So do continue with your descriptive statistics. Go to parameter estimates. This all we covered. Parameter estimates. How does it work? Are they negative?
Yes.
Yes. The higher the perceived remuneration and CD, lower negative, lower the intention relief. Right? So that concludes.